Bjørn, hello.
Hi.
Maria,
Hi.
hello.
Hi, everyone. Really happy to be here.
Okay.
So I'm really glad to be here today with Bjørn, who is an architect for NRK TV, and who will today tell us about how we can simulate some service outages and some service errors so that we can later build resilient services, which is, of course, very, very important since when you have some trouble in your TV translation in Friday night, it's really, really gets people frustrated. So we can't allow for that. So Bjørn, really happy to be here today.
I'm really glad I could come. I would like to go to Russia physically one day. That would be even better than traveling virtually. But I guess this is the best we can do for now. So I've been very close to Russia. I've been to Kirkenes in Norway, far north, but I've never actually
Hope to
crossed
see
the
you
border,
live
so,
someday.
Yeah, me too. So, but I'm excited for today. So
Bjørn,
it's good.
how about a COVID in your country? Situation in your company?
Does everyone work from
currently?
home?
Yeah, I work for NRK TV, so we make a streaming service. I can show you, it's like Netflix or we're like the BBC in Norway, so we make this, like a video player. And everybody who works on the digital side of this product works from home now. So we all sit at home offices. But of course, the people in production and the people in the TV channel.
Did it receive more users because of the quarantine?
Yes,
That's expected.
we did. Yeah, very much so, especially when things closed down in April as being the main news broadcaster. Luckily, we had actually started doing quite a lot of resiliency work before that. So we actually managed fine through those increased loads. But that was exciting. Yeah.
Yeah, because a lot of the services had problems with performance because of the raised number of customers. For example, earning platforms, I'm working on one of them now. That was quite a problem.
Yeah. So,
Ну что ж, let's start.
Yeah. Okay. So this is a workshop, so I just want to go right into it. I mean, I have presentations that I have linked to in the GitHub repo, which is talking more about like why we do this and the business justifications for resiliency and so on. But this is not why we're here today. Today we're here to get hands-on and to code and to get a really feeling for what we're talking about when we're talking about building resilient services. And the first thing we need to do is to get everybody up to speed. So make sure everybody has a working system to work on. And I will go through how to set the system up. And after I've showed that in 2 different ways, we will just have to use the chat and make sure that we have everybody online. I cannot go to your laptops and help you, so you just need to be patient and make sure everybody's up to speed. So there are 2 ways to set this workshop up. And the one is to use the Visual Studio code spaces. And to use Visual Studio code spaces, you need to register. You can go to onlinevisualstudio.com and register. And this is by far the easiest way to get everything set up. All you need to do then is to click Create Code Space, and you can choose a name. And we can say this is the workshop 1. And I add the link to the repository here, which is I shared this many times, but I can put it in the Telegram chat just to be 100% sure. And so you add this to the Git repository. You say what kind of machine you would like to run this on. I'm happy with a small Linux box. And you click Create. And now Visual Studio is setting up our development environment in the cloud. This will take some time. And it will build from the repository. Everything is configured to build and set everything more or less up automatically. So this, of course, requires you to have an account in Azure. As long as you remember to delete all your resources when you're done, it shouldn't be too expensive to run. But the thing about running these online workshops is that we need to be comfortable with things being quiet, because people need to actually be able to do stuff. So I will be quiet for a lot of the time to be able to let you guys concentrate.
There is already some discussion on how people are doing. Some are doing fine. So there is one question about an exception. So somebody is running the run build task, run and watch web API.
Yeah, I can see that. What I think I know what they have missed. I will go through how to set it up physically afterwards, and maybe I think they can have skipped that kind of dialogue where it says open in dev container. I will go through that when we get to doing it on your own machines. I'm just going to go through how to set it up first in the cloud. So now everything is set up and finished. So this is now we have Visual Studio Code in the browser, and we have the development environment set up. So I'll just show how to do it here, and then we'll show how to do it on your local machines. It asked me to install some recommended extensions, and I just click install. And now more or less everything is ready. Now we need to run those 3 build tasks that it talks about in the README, and I need to do Control-Shift-P to get the run task. Since this is in a browser, I need to have the focus on the right place, otherwise it's going to ask me to print stuff. So I just click here in the terminal and do Control-Shift-P. And if it doesn't say run task by itself, then you can type in tasks and run task. And you will select this first, tasks, run task. And the first one I do is I do setup logging and dashboards.
Is the order important?
Not really. If you run the tests before everything is set up, then the test will fail, but the order is not that important. But this is the, I didn't pick up on this. So now this is how it looks like when you run successfully this kind of setup or dashboard task. Now I can do Control-Shift-P and run task again, and I can do run and watch web API. It's better to select this run and watch than run, because run and watch will reload and rebuild every time you save some changes in the API that we're going to work on. So you can run this. And now we see it starting the API. And it's going to be green once everything is set up. So now the web application is running. And I will show how everything fits together afterwards. I'm just going to show you how to do it now. And then you can do run task. Oh, it's better to do enter actually. Run task and run K6 test. And I shall select the intro one. And if everything is working now, we should start running K6 load testing. We'll go through how this actually works later, but I'll just make sure that we see that this is working. And now I can look at how this looks in a dashboard. Then I need to click this Remote Explorer button here, which is this screen with symbols on. And the port 3000 is the one we want to select. This is Graphana, and we can click this opening browser here. And this opens Graphana, and we can select these 4 squares and then manage. And we can find this intro dashboard. And if everything is working, we should see some data coming into the dashboard. So this is the steps we need to do to set things up if you run it online. Now, if you want to do it on your own machine, it says that you need to have VSL or on Linux you don't need that, but and Docker installed and set up running, and then you can clone the repo. So you can do git clone and git clone the repo, and then enter into the catalog. So I'm in the root folder of the repository. And then you can type code and dot to open this folder in Visual Studio Code. And this should open Visual Studio Code and open the folder that I'm currently in. And this is the step where I think a lot of people might be missing something. Because right now it will open Visual Studio Code and it will find this magic dev container file, which is setting everything up. And you need to select this reopen in container. And if you don't do that, then everything will fail afterwards. So this is a step that I think a lot of people might have missed. So if you click reopen in container, you can do file open folder as well, and just open the folder and it will find this. And then it will reopen the solution and it will set up all the containers for you. And this will also take some time because it needs to download all the dependencies and Docker images and start them and so on. So this is the one step that I think people might be missing. So you can do also open folder and just point it to the repository, and it will ask you the same thing in the bottom corner here. And you need to select the reopening container. After that, the things are really much a lot of the same, almost the same. You can do Control-Shift-P, and you can run task, and you can do the setup logging and dashboards, run a watch the web API, and run the tests. One thing which is different now is that in order to access Graphana, you don't need to click that remote explorer because you have it on your machine now. So you can just go to localhost port 3000 like this, and it will open Graphana. And then it's the same. Select the 4 squares, manage, and intro. And if I go back to Visual Studio Code and do Control-Shift-P, run task, run intro test, it should start and run a test and log data to my dashboard like this. So these are the 2 ways. They're documented in the README, and this is the point where we need everybody set up. So if you have any questions, ask me in the Slack, and I will try to answer them as best I can. And we just need to take our time and get everybody set up.
Bjørn, you told me that you found that during your workshops, you see that people usually prefer to run everything locally, not in the browser.
Yeah.
Why do you think that's the case?
I have no idea, but it's this is interesting. Because I like this running it in the browser and running everything in the cloud, but I think developers want to have it on their machine. They just want to have it running on their machine, and I think it's just the way we are. It's like you see this, you can put this in the cloud or have it on your machine, and you're like, I put it on my machine, even if it's more work. So I don't know. But this is the way this is. I'm the same. I'm a developer myself, so I do the same.
Yeah, I did the same thing too.
Do something. Yeah. Someone asks you, "Can you do this?" And you're like, "No, I'll rather do it my way." And this is it's the same every time.
Yes.
So let's see if someone has any problems now, because there are some people. I guess I need to help here. So if you
they have the same problem that I had. So they have K6 tests, which is good, but some issues with the Graphana.
So one thing with the Graphana is to actually find it, because like the Graphana user interface, when you enter it, you don't know where to click. So you have to hover over these 4 squares here and then click manage. Well, maybe there's another way, but this is the only way I know how to find them. Yeah, and then there's some MS services maybe that don't work in Russia for people, which is, and then there's that also might be something. So it's yeah, and of course, yeah. Now, the good thing about having it work on your machine, as is mentioned there, is of course that it's it makes it easier to just pull it into your projects afterwards. Of course. Cannot create Azure account. Oh, yeah, politics too. So that's. But if you click this, you should find the dashboards here. But the dashboards will not show up before we run this Control-Shift-P run task setup logging and dashboard. So if there's nothing in the Grafana tab, it's important to run this to first run this setup logging and dashboard. You will, when you click enter, it will also ask you for something like scanning, continue without scanning the output. So you just select this first one, continue without scanning the output. The good thing about the Grafana part is that it's not critical. You don't really need Grafana to run the workshop. It's like a nice add-on. So if you have any problems, we can run perfectly without Grafana and the dashboards.
So it looks like several people have the same issue that I had without dashboards.
Yeah, and that was that first. Well, you can.
Why set up?
Okay, okay, yeah. So first you need to do run task. So you type run task first, and this is the thing. First you do run task, then you get the different tasks. So that might be an issue. So you do. If you take Control-Shift-P and then set up dashboards, there's no matching command. You do first run task, and then you get the selection. I can show you all how it's set up here too, because there's this magic file in here that says tasks.json, which is basically all we're doing is running this script. So you could probably just also copy that and make a terminal and run it in here, but this is where all the tasks are defined in this file. It looks like
yeah.
And this is the thing, is like Visual Studio Code and discovering things is like, if you know how to do it, then it's fine, but it's not all the time that intuitive. Okay, it worked. So I'm glad it looks like people are coming on board. I just want to make sure that we're not missing anyone before we move on, because we have quite good time to go through these things. And for me, the most important is to get 1, 2, and 3, 4 of the 4 first challenges done. So I just want to make sure we have everybody on board. So my question now is really, are we missing anyone, or are everybody up to speed? And we could start doing the workshop.
It's good to see that people are helping each other.
Yeah,
in the chat.
Yeah.
Yeah, it looks like.
Okay, I think we're just going to start and then just stop me. So then I will actually explain a few things of what we have set up, because like a lot of the stuff is just magically set up, and it's good to know what we actually did. So this workshop is going to use 2 concepts. It's Simmy and Poly. I think quite a lot of .NET developers have heard about Poly. It's the resiliency framework that you can configure to retry operations or timeout operations and so on. And Simmy is sort of the bad pirate. He's the chaos engineering little monkey that is causing all sorts of problems. And the nice thing about this too is that it's the same sort of framework or library, so they play very nice and easily together. So Simmy can simulate problems for us, and this is what we're going to do today. This was just a little bit about NRK, but I think we're going to skip this. Yeah, so we're going to go through this in code example, but so Poly and the library is letting us define this kind of policies, which is what are you going to do if something times out? What are you going to do if something fails? How long are you going to wait before you will assume something has not worked? So we can define these policies. We can compose policies, so we can take different policies and put them together and make new policies. So this is nice. You can take a policy, another policy, and make a more complex policy. And when you have a policy, you can execute things in it. So it can take a function, which would be, in this case, this is from our production. So this is get this clip, which is like a media playback thing, get it from storage, async. And we can execute this within the policy. And this is what we're going to do today. So the Poly documentation is also very good. So you can, if you need this during the workshop, you can look it up online and actually try to see how things work as well. I will give you time to do this. These are all the things that we've like sort of set up now. So we have Visual Studio Code and .NET Core, which is running a web API. I will show it very straight out of the box web API project. We are using K6, which is a load testing framework to load test the application, because simulating one error is not so interesting. What's interesting is what, in my opinion, is what happens to our application when we load it and introduce latency, for example, and how we deal with that. This is when things tends to blow up in production, is when things start to get slow and we get increased load and that sort of thing. And this is what we want to work with. So we use Simmy and Poly to handle retries and introduce errors. Then we use InfluxDB and Graphana and Telegraph to visualize what's going on. We don't really need it, but it's nice to be able to see some graphs sometimes. So the first thing we're going to just look at is to see, we're just going to look at the API we have in an intro challenge and using K6 to it and just see how, with no Poly, no Simmy, nothing, just see how things run. And then we're going to introduce some tasks. So this is the introduction controller, which is called intro controller. It should be in your API under test controllers and then intro controller folder. So this is a very standard .NET Web API controller. It's the one that comes with a demo, I think, this weather forecasts. So it has a constructor, and it has one operation, which is get, and we will asynchronously get the forecasts. And in this case, we just wait for 1 second, and we select some forecasts. So I can open this. Hold on. So we can open this in the browser like this. And of course, we can load test this by clicking F5 many times, but that's not so efficient. So we have K6 that we can use to do it. But if you want to try, you can go to localhost 5000 and then weather forecast intro, and you will see that you get the reply. And I'll show you how to fire up the load tests as well. So under K6 tests folder, there should be some test files, and the challenge intro test is the K6 file for load testing. And it says here it will run for 1 minute. That's actually quite a lot of time. You can choose 10 seconds if you like. These are requests per second. We tell it to just throw the response bodies away. This is just because we don't really need to look at them in this case. This is just copy paste from our production code actually, because this is it just sets the user agent to the test so we can identify it and so on. And these are the thresholds that we will introduce later that will actually fail or pass the test. Currently, we're just asking this one to go and get the intro, check that it's okay, and well, nothing else is really happening. So we can do Control-Shift-P, run task, and run K6 test, and select intro. And it should run now for 10 seconds. And maybe you can post in the Slack what kind of response rates you're actually getting. Now I have zoomed in quite a lot. If you have a little more standard resolution, you will actually see this on one line. So we can see how many, if you could put in this chat, how many requests you were able to make in, I was able to do 5,000 checks. HTTP requests 5,000. I was able to do 490 per second. So we've hard coded it to do 500. So you could put in that, and if you could put in the HTTP 95 percentile, which is hit this one. How long does it take to run the 5% slowest of the calls? If you could put that in the Slack, then we'll see that it's working.
I actually have rather different numbers.
Yeah, and one thing I really saw is that before we moved to Docker, there were huge differences on Windows and Linux, but now everything is running on Linux in the workshop. It was very hard to make tests because Linux was so much faster than Windows.
So that one that you had 100 something for iteration duration, I have 310 there.
Yeah. And this will also depend on what's going on your computer and so on, because these are the slows. Yeah. Someone has 108 milliseconds, and this we can see here. So the rate we can see here, K6 tries to make approximately 500 per second, but this is not an exact science. And we can see here
could you tell shortly what is in this graph so that we understand what to look at?
Yep. Yeah, so rate of 200 OK is how many percentages of the requests are OK. So how many are responding with 200 OK. And in this case, everything is working 200 OK. So all the requests are successful, seen from K6. These are how many requests K6 are able to do per second. So we ask it to do 500, but this is not, cannot exactly predict it. So it tries to do 500. These are how long the request takes seen from K6, not from seen from our call, which is after the connection has been made and everything has come into .NET. This is actually from the client side. So you can see here that the minimum required is 2 milliseconds. The average, and the 95 percentile, which is the one I normally care about a lot of the time, is 2767. So this is the slowest 5% of the call.
So just to go through the definition, 95 percentile, that means that 95% of the requests are faster than 22 milliseconds.
Yes.
That's the...
Yeah, so this means 95% are faster than this. That's the easiest way to say it, I think. So, and normally what we see when we tune for performance is that average is not so important. Minimum is not so important. It's the 95 or 99 percentile that you want to be looking at. Those are like the maximum time is not so interesting because that's normally maybe something is slow, like a random thing was slow. But 95 or 99 percentile, these are the one numbers that you want to look into normally. That's my experience. So now we can try to change it. So now we can try to go into the challenge one controller, challenge intro controller, sorry. Challenge the .NET controller, challenge intro controller. And we can try to add some more delay. So let's say we do, you can choose what number you like, but maybe 200 milliseconds. So this line 34 in intro controller. And then when we save and we look at this, you can select the terminals down here and you can see now I saved it and it's restarting the application. We don't want to run the load test until everything is started again and everything says green. Otherwise the load test will get some issues. So if you do this and you do run task again and you run the same test, now we should see some different kind of behavior in the application. Now everything should take much longer. So you see now the application is much slower, which is expected because now everything has to wait 200 milliseconds. So now everything got a lot slower. And we can see that we're actually not able to do 250 requests per second. But everything is still working. Everything is still 200 okay. So I would just like everybody to try that because this is like the basis we need to have set up to make everything work. So so the main point is to try to change something, save it, make sure things has restarted, so it's green again down here. That is picked up the changes, and then rerun the test.
So people are posting their results in the chat.
Yeah.
If you want to have a look at them.
Out of memory. Yeah. Out of memory. That's. I don't know what happened there. I'm sorry. If there are any questions now, like please ask them now because things are not getting much more difficult, but we are adding Poly and we are adding Simmy, so it's good to get this stuff set up. If you're having problem with memory, I would suggest maybe trying to reduce this VUs, which is the virtual user setting. This is how many sort of processes or virtual users K6 is setting up. You can try to put this down to 10 maybe, and try to decrease the requests per second. Try to decrease this. Yeah, it looks to me like things are working. So I think we're ready to start with the challenges. The challenges are in the README as well. And I will go through the first one a little bit. So in this one, we're going to introduce 15% socket errors. Socket errors is just something I see in production all the time when we have problems, so that's why I put it in. So I simulate socket errors. They're not real ones. I just make in the challenge one controller. I just make a new exception. So this is the one I hate the most from production. It's socket exception and TCP sockets running out of ports and all kinds of things, but it's not so bad when we make them ourselves. So we just make a new exception, and then we ask our monkey to inject this exception in 15% of the cases, and we want to turn it on. This is you can configure things on and off. So we sometimes use feature flags to turn things on and off in test environments and so on. And this is the toggle, but in this case we have it always on, 15% exception rate, and then we make this. We say we're going to make a policy which is in the inner loop. It's the chaos policy that inject errors, and then we're going to get this policy here, and this lets you try different retries. So this is the variable that you should change in this assignment to get the right answer. And we will execute our get forecast method within this policy. So what will happen is we'll introduce 15% errors, and this is how many times Poly will try to retry this operation. So if you now run task and you run K6 and you select test 1, we will load test this test, and we have some requirements in this test. We want the OK rate to be higher than 99%, and we want the request duration to be less than 200 milliseconds. So as you see here, given that 15% of the internal methods fail with a socket exception, when we load test the API for 250 RPS for 10 seconds, we expect the failure rate to be less than 99% and the latency to be less than 200. We can find this dashboard here, and when we run the test, we see that the rate of 200 OK is not close to being in the green, which is the 99%. It's 85%, which is okay because we introduce 15% errors. And we have the latencies and so on. And we can see in the output from K6 here that it says errors and pressures have failed. So the OK rate and the OK count is not high enough. So what I want you to do now is to play with this retry number, run the tests, and see what happens. And when you get the green test, I want you to report how many retries did you try, and then in the chat, how many retries did you have to put in to make it work, and what are the different trade-offs that we make. And now I'm going to try to be quiet so that you can actually think and run this yourself. And if you have any questions, I will try to answer them offline in Telegram so that people have the chance to think without me talking all the time.
So Bjørn, while everyone is trying these things out, I have a somewhat unrelated to this test question. So about this Simmy, like you said, poly is something that I know and use, and Simmy is something that I see for the first time. And is it designed to work specifically with poly, or can it be used to also be working with self-written resilience system? Or so, for example, I have written something myself. Can I also use Simmy to test it, to simulate
Now
the errors?
That's a good question. I have to think about that because they are working very well together. I would imagine you could do that because I would imagine you could, depending on how that resiliency framework is wired up and how it's working, because you can easily just run the chaos policy, and then you would do that, and then you could run your resiliency framework on the outside. So I'm pretty sure you could. But the beauty of Simmy is how well it plays together with Poly. But I think if you just did this, you would actually, if you just did this, you would just run the chaos policy, and then you would have to put your own resiliency framework outside here, and that should work. But of course, it depends on how that framework is set up.
People starting to post the answers, so they seem to be happy with 2 retries.
Yeah, that looks fine. So I think 2 retries work some of the time, and then not all the time. Because this is retries is math, right? So I have a slide here that I can show. I think it's down here. So this is just the architecture of everything, how things wired up. We're going to skip this. Hold on. Yeah. So because right now we're just doing dice rolls. So if you have a 10% chance of success, you 10% error, you have a 90% chance of success. If you do retry it, it starts to reduce the number of the chance of success. And with 15% errors, and we wanted to do 99%, you can actually calculate like a number that should work most of the time. But there are no, you can be unlucky as well. And there's a question I'm going to answer as well, which is how Graphana actually gets the config values. I'm going to explain that as well, because that's a good question. So 2 and 3 retries works fine, right? So you have all done this, but I can just do it just to make sure. So we changed the retry here, and I'm going to explain the part about Prometheus as well. So if I make 1 retry, this is what you've been doing, so I'm just going to do it quick. I save it, I wait until it started, and I do run task, and now it's green, and I run task, and I'll just watch it in Graphana. And we see this configured retry number now jumps up, and the executed number of retries, how many retries we've actually done, is also jumping up, and I'm going to explain the little bit of magic that happens behind the scenes to post this to Graphana. And then we see the retry rate at 1 was 98. I think I could maybe try to calculate it even in Excel, like you have 15% chance of success, and you do 1 minus this one. Oops, sorry. 1 minus this one times this one. So 2 retries is 1 retry is 97%, and then you can do. So you can just roll the dice many times, right? Changing keyboard setup so many times I get confused, but yeah. So with we get 99% if we have 2 retries here. So that should be both mathematically correct and practically correct. So then we should be quite happy. I can just run to make sure it's green again as well. It looks like everybody has been doing it, and then we'll run it again. And I think the really interesting part, which is like, you're all doing it now, but to me, the interesting part of this is to make what is normally quite just what is good enough. It's not so easy, but we actually can make red-green tests that we say, given this many errors, given this much load, then we expect this kind of performance. When we do this so strict as we do here, we can actually make it into a red-green automated test, and we run this in our development or in our CI system now. So we can start to be very precise about what we mean about something which is normally quite vague in a lot of cases. And now I'm going to explain the little bit of magic that happens for Graphana, because I had a question: how does Graphana get all these numbers? The first one, which was not the question, is that when we actually run this task, here it's run in here, we say K6 run and we run the test. We just say run this test. We tell Graphana where to find the influx database. No, we tell K6 where to find the influx database. So all the K6 metrics are being reported directly by the K6 runner. But as is being asked about here by Nikita, is, but how does Graphana know about our internal stuff? And then that's using this Prometheus gauge here. So I just made some inside here. This is just like static gauges. I just did it as simple as I could. So I have this Prometheus.NET runtime and Prometheus library put in here. And it says make some kind of gauges. So I can write to these gauges. How many connections do we have? How many retries do we have? How many garbage collection generations are we running, and so on. And when we set up the web application, we also say set up a metric server at 1, 2, 3, 4. So this means that there is another web application running at 1, 2, 3, 4/metrics that is exposing these counters. So executed retries 158, and this is being scraped by Telegraph and put into Graphana. So I can show you the diagram for how this is done. I think. Hold on. Yeah. So Telegraph is running on one of these Docker containers that's magically been set up, and it's scraping the metrics from /metrics, which is the Prometheus protocol, and then inserting that into InfluxDB so Grafana can get it. So Telegraph is actually scraping, but that means that you can, if you follow this setup, then you can just write to these kind of gauges and you will find them in Grafana. So I set the number of retries and I publish them, and then they're exposed. And what I do as well is that in the retry policy, I just say every time you retry something, increase the executed retries counter. So then we can know a little bit more about what's going on. And we also have information, which I haven't included it in the workshop, but it could be interesting to see what's happening to the garbage collector, what's happening to, as we load the application. Maybe not so much with resiliency, but like if you want to test how it performs under load and how you allocate variables and so on, how it, different kind of performance analysis you can do. So that's a little bit behind the scenes. And we can go back to the workshop. So in the next one, we are going to introduce not errors, but latency. Latency is what is normally killing our application, at least what's killing my applications during load, is when things become slow, but the users are still loading the application, and that when threads and resources are being kept open and the whole web application crashes on you. So this is and we can use the same Simmy monkey and inject latency. In this case, we say 1 second in 10% of the cases. And we now have you can change the timeout, which is now configured to be 30,000 milliseconds or 30 seconds, which is close to many default values. Really, it's like a lot of things time out by default after 30 seconds or 60 seconds. And we can see, and it says we have a requirement to be faster than 200 milliseconds. And it says that the correctness requirements are not so hard to meet. So what I want you to try to do now is to try to formulate this by reading the K6 test in challenge 2. Try to formulate something like this and put it in the chat, like something like given, when, then kind of thing. And then try to solve it is in the same way, but just changing the timeout. And just post the answers and the given, when, then syntax in the Slack.
Yeah, I also got this from time to time when I forgot to start the API. So if we don't change anything, we get the error on HTTP request duration, right? And then we need to change something.
Yes. There's the timeout async policy here that's being
By the way, it's not very obvious to me when I change something and whether it has been already updated or not. So there is no clear indication. Or I can restart the tests immediately after I change the timeout or whatever.
Yeah, I put the screenshot in the Telegram Slack there that says that if you select, I know what you mean, and it's a bit annoying, but if you select, if you click down here with the terminals and you select that run and watch web API task, you will see if I save something, you will see that it says exited, file changed, watch started, and then you have to wait until it goes like green and listening. So now it's rebuilding, and now it's finished when it goes all green listening. So
I think I
like
might be
normally
missing
when you run
sometimes.
yeah, because when you're running the test, normally you're sitting here and then you don't see what's going on, and you save and you run the test, and then everything fails and you run the test again and it's fine again, and it's
yeah, and that's confusing.
Absolutely. It is. It's yeah.
So how does
if someone is interested, it would be fun to have. I mean, it is definitely possible. We do that in production. Change these variables by configuration. So we have in pre-prod environments, we can actually have feature toggles that change this, so we can actually change it on the fly without starting the application. So when we load test 8 instances under high load, we can change how things perform. So it's definitely possible to make this configurable and not having to rebuild the application. But I wanted to sort of make the code as straightforward as possible. And then we unfortunately need to rebuild.
So people are formulating the
Yes.
requirements.
Yeah. Yeah. Oh, yeah. Visual Studio Code crashed, unfortunately. Yeah, but I think that yeah. And the reason I wanted to try to be explicit is that for me, this was like the main insight of this entire thing was that is formulating those being, because this is what I've been able to then go back and to talk to product owners and different people about, like, okay, so what do you mean by resilient? Like how much should we, you know, how what is good enough? And we can give this to our testers, and the testers can test against it, and you suddenly get a language for something that is often quite vague.
So these numbers, they are kind of also formulated by your team. It's not from some, golden standard of some industry. It's just you have watched how it works
Yeah.
in one
Yeah, well,
build, then change and see that it's better, etc. How did you get the
yeah,
numbers that you want?
the main numbers I got from talking to the chief of the TV station. Okay, how
Yeah.
often do you want the main services to work? And I said, like, can we do 4 hours a year of downtime, like 99.95%? That's that's hard enough. Like that includes signals from cameras and everything, right? That means that their APIs needs to have a 99.99% uptime. Like and then so that's the high level thing, but then you need to break that down to latency and errors and so on, and that's a little bit of reading the Google software reliability engineering handbook. Is it Google? I'll find it. I'll put it in the Slack. So there's this book, Site Reliability Engineering, and we took a lot of the lessons from Google. We're not doing everything that they're doing because that's very expensive, but they talk about 500 internal servers, exception rates, and so on. And then, but actually setting the numbers is just that's it's the difficult part. But what we find is that once we come up with some numbers, we can test and we can adjust those numbers. So it's still just like a tuning handle for performance, and for us it differs quite a lot. But of course, in the case where we have some APIs that have a 99 percentile of less than 10 milliseconds, and in that case you just don't need a lot of instances really. And but in the case where you have 5 seconds latency in some cases, then you need just to scale out. So you need to buy more servers really if your API is slow. So Nikita,
The reason why I ask about the exact numbers is that you don't always have this in the form of a request from business. I mean, it's probably in some way easier if business knows what they want, but for example, in our cases, they just want things to work better. But it's nice to have some rigorous metrics so that you can see you've refactored something. It's better or it's worse.
Yeah. No, this is the thing, that what the business has seen now is that we have stopped crashing, right? We've stopped with this crashing under load. So they can see that, okay, so whatever kind of thing engineering we're doing, it works for the business, right? But yeah, coming up with the numbers, no one wants to come up with a number. And this is a very good question, because like the tests, I say, oh, maybe the testers should come up with the specifications. Oh, no, the tech lead should come up with the specification. No, the product owner should come up with the specification. No, the architect should do it. And everybody just points at it. At some point, someone has to just go in and say, if you cannot make up something, these are your numbers. And then, if you want to change them, change them. But I think, like, when someone comes up with some numbers for the first time, then we have something to discuss. And then if someone says, no, but 100 milliseconds, we cannot do 100 milliseconds. Then we can say, okay, so what can you do? Oh, I can do 500. Okay, so do 500. And then we can run with that for some time
So
and
it's a
get some
start.
experience with it. And it's a start. And then, but you need to be able to change those parameters. Like if you put them in stone and you say you're going to get your, bonus, you're going to get, 10% bonus if you can meet those numbers, then you have a problem, right? Because so, because then people will start gaming the numbers and playing with them and cheating. So yeah,
Yeah.
for a lot of people it's been good because now so we say there's some
People seem to get start to get results, and interesting that they are different for different people. For example, for Nikolai, he says that he got a challenge to test passed just with 150 milliseconds, and for Matvey, it's passed with 100.
so
So around that
there,
numbers.
there's some good questions there. So I think Nikita has a very good answer. He says that the average latency is 20 milliseconds. So to get past 200, it should be fine, with 100 or 150. It's true. But I don't see where retries are configured. And that's on purpose because we didn't configure retries. So because we don't, in this case, we don't really need to be correct. I didn't have any specifications on that were very strict. So it's fine to crash. And in some cases, I put it in on purpose, just first of all, just to introduce latency by itself. We just say here that we only need 85% of the requests to be correct. So it's fine if we throw away 10%. Well, this is probably, a made up number. No business would probably say that, you only need to be right in 85% of the cases. But the idea is that in some cases, it's better to fail fast and give up. And you can only know that by knowing your application and what it's doing. Is it better under load if things starts to become slow to just kill the requests and move on, or do you want to retry and retry and retry? So this is a
was our
trade-off, really.
problem, because we had some exceptions that took a lot of time, and they were retried and retried and retried, and that killed the performance.
Yeah. So it is really a difficult balance, and you need to. So this is like why I put it in, because people get confused by it, and it's a good learning opportunity to just think. But maybe you should fail fast. Then there's another question about how K6 and API under test interact. Yeah, we configure Simmy, but it seems to me Poly is part of an API client, but we configure them in the same place. Yeah. So the K6 tests are on the outside. So the K6 tests, they actually go to your API and ask your API, call them over HTTP, measures the response and just from the outside, and it just checks that everything is okay under load, like basically like a browser would. Whereas Poly and Simmy are configured in the same controller. And normally in production, you would not run with a chaos policy on. So this is maybe why it gets a bit like, this is something you do when you test it, you would turn it off. So normally how a poly application looks like, if I just do, is this is how a normal application with poly would work. So you would go and get your, in this case, your, or it could even look simpler. It could look like, it could look like this, basically. I just, this is what poly could look like. So you make a timeout policy of 300 milliseconds, and you execute whatever thing you need to do, your database call or your HTTP call or whatever, inside that policy, and then poly will take care of everything. So this is the role of poly, and this is the role of K6. And then Simmy makes this a bit more complicated by injecting someone who is causing trouble and we combine that retry policy or timeout policy with our chaos policies, and then we do things inside the API. So this would be do a database call, or call something on HTTP, or do something computationally expensive or something like this. So the tests pass with 100 milliseconds, but they did not pass with 150 milliseconds. And this can be just, during, and this is also, I think, is just interesting because the thing is that these are stochastic numbers, and there are other things that takes time, right? As you experienced, it's just not just the delay, it's not just the idealistic time. There's other things going on in the machine, and maybe the garbage collector is pausing stuff, or maybe the machine is doing something else, or maybe it's just 100% CPU, or so there are other things that are slowing your machine down. So we cannot put this theoretically idealized numbers at 21 milliseconds in the application, and this is something we get a little bit of experience with running from this. Yeah. Yeah, and this is probably a better explanation. If we want to talk about 50 users during 6 seconds, creating 500 RPS load. This is probably a more specific way of saying it than what I did. Yeah, and it says retry, kill depth, kill infrastructure. Yeah. Then this is, and then there's some errors with Visual Studio Code that just Vadim, are you able to do things, or is it just always crashing? Because I could try in the break to set something up for you in Visual Studio Online that you could connect to. And this is really now you've seen like how the workshop is built up, and I'll just give a little, because we are it's a break coming up now in 3 minutes, isn't it?
Yes, that's correct.
Yeah,
I have some time for coffee.
Yeah, that's good. And I need to relax a bit. Yeah, and challenge 3 and challenge 4 is very much building on what we did in challenge 1 and 2. So this is combining the stuff that we've done into making something more realistic. And challenge 3 and 4 is that. And this is, to me, the most important part of the workshop. Then the challenge 5 and 6 and 7 is the stuff that I hope we have time to do after we've done 3 and 4. And has more to do with, I would say, .NET, how things work in .NET, the cancellations and some other specialized cases. So yeah, because I don't think we're going to start challenge 3 now before the break. So I think we could just, if you have any more questions or something, we could do that now.
Maybe you just tell all this thing appeared. Was this for your colleagues for some onboarding? How was the birth of this
Guys, what's up?
challenge?
I'm come back.
Yeah.
For how
Bjørn,
we...
эксперт Мария. У нас хорошие новости. Вы можете немножко отдохнуть от кода, от воркшопа. Давайте вместе все поблагодарим в чатике. Вот там в чатике. Давайте всех поблагодарим в чатике эксперта Марию, Бjørна за первую часть воркшопа. Bjørn, did you complete all plans for your first part workshop?
Yeah. Yeah, I'm happy. It looks like everybody was doing well.
Okay, what we can expect in next workshop part?
Yeah, so in the next one, we'll combine what we did in the challenge 1 and 2 in a little bit more combining retries and failures and timeouts. And that should be, now that everybody's set up, that should be fairly quick, because that's more of the same of what we've been doing. And I think everybody sort of, from the responses, it looks like people are getting that. And then we'll do some more advanced stuff with cancellation tokens and killing requests once you close TCP connections, and doing some more ASP.NET and .NET specific kind of things. And we're also going to look at some things that I've seen sneak up on me in production that was unexpected, that turned into a challenge. Yeah, so it's just...
Окей. Напоминаю, что воркшопов в записи не будет, и лучше смотреть этот самый крутой воркшоп в записи. Не в записи, а в онлайн-трансляции, следующую часть обязательно смотрите. Извиняюсь, я ошибся. Этот воркшоп Бьорна будет в записи, так что не переживайте. Небольшие неполадочки. Так, ну, давайте еще раз поблагодарим Бьорна, Марию. Спасибо вам за крутой воркшоп. Мы к вам вернемся в следующей части.